JAL1628 on radar. This presentation does not intend to examine the events of 18 November 1986 in detail, but instead, evaluates the data subsequently made available by the FAA. Part 1. Murphy Dome. The principal data made available by the FAA consisted of a printed report, a standard CDR editor listing, as used by air accident investigators. The data in the report was obtained from the Murphy Dome long-range radar. In order to limit the amount of data requiring manual analysis, the FAA selected a portion of the radar's total footprint. The selection criteria of a CDR editor listing allows the user to specify a minimum and maximum range as well as a minimum and maximum azimuth. This initial data list included only a fraction of the total data available from the Murphy Dome radar, as can be seen by the flight path of JAL1628. Before we look at the radar data in more detail, it is important to understand the relevant terminology. Part 2. Understanding recorded radar returns. The FPS-117 is a sophisticated radar. As well as determining an object's bearing and range, this 3D radar is capable of independently determining an object's altitude. A primary radar works on the principle of echolocation. The hardware transmits a radio pulse and then listens for the return echo. The strength of the return echo depends on several factors, including the reflectivity of the target object. Because primary radar is subject to anomalous returns, modern air traffic management requires aircraft to carry transponders. A secondary ground radar system transmits a signal, causing any receiving aircraft transponder to automatically respond. The reply usually contains the aircraft altitude and transponder ID. Some radar systems are beacon only, and are also known as secondary surveillance radars. Many air traffic control radars combine primary and secondary radar systems. When these systems record data, the hardware automatically attempts to match primary returns against secondary returns. A successful result is recorded as a reinforced beacon. Occasionally, we may look at a radar recording and expect to see a reinforced beacon, but instead, see a primary return and a beacon return. These instances are referred to as split beacons. Part 2 Summary. Secondary returns are also known as beacon returns. Primary returns that are not matched with secondary returns are also known as uncorrelated primary returns. Part 3. More data. As well as the initial CDR editor listing, the FAA released more data in the form of additional CDR editor listings. These reports cover different sections of the JAL flight through Murphy Dome's area of radar coverage. We will refer to these data listings as reports 2A, B, C, D and E. While reports 2A through D were limited by distance and azimuth ranges, report 2E contained every beacon return from JAL1628. We will return to report 2E later. Part 4. Animation. JAL1628 is the aircraft entering radar range from the northeast and approaching Fort Yukon. This animation displays the data contained in reports 1 through 2D. These data were entered manually from the listings provided. A computer program converted the raw data into the format expected by the animation software. Part of the process involves converting azimuth and range data into latitudes and longitudes. This conversion process requires knowledge of the location of relevant radars and an estimation of the magnetic declination required to convert bearings from magnetic north to true north. Green and blue dots indicate transponder returns. White dots indicate uncorrelated primary returns. Towards the end of the sequence, you may note the two changes in course made by a C-130 to fall in behind the JAL aircraft. Part 5. Obvious anomalies. The track of JAL1628 shows two significant anomalies. The first appears to be due to the aircraft's close proximity to the Murphy Dome radar. The second consists of ghost beacon returns. This could be an example of false returns unsynchronized in time, also known by the acronym of FRUIT. This anomaly can occur when an aircraft transponder responds to the signals of more than one ground-based radar. Part 6. Uncorrelated primary returns. An overview of the available data provides explanations for many of the returns. These include returns relating to high-altitude terrain, an aircraft without an active transponder, and probable instances of split beacons. In summary, there is no statistically significant radar evidence of the objects described by the crew of JAL1628 in the data made available by the FAA. In other words, there is no evidence of an unknown track or tracks. However, our evaluation is incomplete. The FAA claimed that two air traffic controllers mistakenly interpreted split beacons for something more significant. There are two problems with this assessment. First, the two halves of a split beacon occur within a fraction of a mile of each other. Controllers reported and confirmed returns at distances of 5 and 8 miles from the plane. Secondly, the ATC transcript relates that these two returns were placed at 5 miles in trail and 8 miles ahead of the aircraft. The first return occurred at 2:25 GMT, and the second at 2:26. The single uncorrelated primary return, immediately prior to these reports, occurred at 2:24:35. The single return cannot be used to explain these two separate reports. Perhaps, more significantly, this particular return was not technically a split beacon, but a reinforced beacon accompanied by an uncorrelated primary return. How can we explain this apparent disparity? The FAA analysis included an interesting statistic. 72% of beacon returns were reinforced. On closer inspection, the statistic only applies to the beacon returns of JAL1628, and only for the data included in the initial report. If we expand this statistical analysis to all of the available JAL beacons, then the positive detection percentage drops to 44%. If we analyze all available beacon returns, this percentage drops further to 38%. Note that virtual beacon 1271 is excluded and would only reduce the percentage further. When compared to a similar statistic from a similar 3D radar from the 2008 Stephenville data, the ARSR-4 shows an average positive detection of 93%. We should note, however, that the effect of the environment, a difference of over 20 years, and possible fruit, may affect the comparison, but it tends to indicate missing data. Additional indicators of missing data include the existence of maximum signal strength returns only, listed within the data. As with the 2008 data, we would expect to see a full range of return signal strengths in the data from 1986. And the returns reported by two air traffic controllers do not correlate with the recorded data. Part 7. Other radars. So far, we have focused on the Murphy Dome radar. However, if we return to Report 2E, there were data from 3 separate radars present. Through a combination of estimation and investigation, it was determined that Radar 2 was the radar to the south located at Kenai, and Radar 3 appears to be the beacon-only radar, located to the north at Dead Horse. Neither of these 2 radars can add much to our understanding of events. However, they are not the only radars covering the area of interest. Indian Mountain Long Range Radar is located to the west, and Fort Yukon Long Range Radar is even closer. Along with Murphy Dome, all 3 advanced FPS-117 radars were installed in 1983 as part of the Sea-Igloo program. No data from Indian Mountain or Fort Yukon were made available. There should also have been data from the short-range Approach Control Radar, serving Fairbanks International and Isle Sun Air Force Base. Note: between the late 60s and 2001, the FAA received data from more long-range radar assets than the military within the contiguous United States. One would expect this model of operation to be similar for the Alaskan region during the same period. It should also be noted that JAL1628 would have crossed the distant early warning line, a separate network of radars controlled and monitored by NORAD. In conclusion, the FAA's own conclusion was flawed, and failed to reflect a fair and complete assessment of this relatively complex incident. Evidence of unknown phenomena must be said to be inconclusive, in part, due to the lack of data, and also due to the lack of full disclosure of relevant data by the relevant authorities. Thank you for listening.